Okay, so I just wanted to go over some more details that I kind of glossed over in the proof of this replacement theorem 2, which is basically that if A and B are terms free to replace X in the formula, well, actually, it doesn't have to be a formula. It can be any term psi. Then we have that A equals B implies psi with X replaced with A equals psi with X replaced with B. Okay, so the bit I kind of glossed over was where I made use of this sort of simplified cut rule, okay, which is basically that if gamma dash implies psi dash and psi dash implies phi dash, then gamma dash implies psi dash. The thing is that in order to use this, we really want every variable in psi dash to be free in either gamma dash or phi dash. And I didn't go through that properly. So let's just look at this proof again. So the first thing is that in general, let's just say that it's true. For example, this is just general kind of reasoning. Say it's true that, say alpha is true. Okay, so alpha is a true formula. Then we want that A equals B always implies A equals B and alpha. So we can see this. Trivially, we get A equals B implies A equals B. Also, trivially, we get alpha. Then using the thinning rule, we get A equals B implies alpha. And then using the AND rule, we get A equals B implies A equals B and alpha. Okay, so we get that. Now, for us, in our case, alpha is this, okay? Because this is trivially true, because if we take our term psi and we replace x with A, and we also take psi of x and we replace, well, we also just take psi. I don't need to put psi of x there. No, we just take psi and we replace x with A. Of course, on the right, that's going to be psi with x replaced with A as well. And we're going to have those two things equal. We basically get that from this corollary of equality axiom 1 that we've already kind of, well, corollary of the equality lemma that we've already seen. It's kind of obvious anyway. So this statement here on the right is always true. Now, it follows then from what I've just said that we're going to have that B equals A always implies B equals A and this thing here, okay? But then we want to kind of use our, but we also have, by our replacement theorem 1, here, we also have that B equals A and X with, well, and any kind of psi, any formula psi with X replaced with A implies that formula psi with X replaced with B. So using that kind of theorem, with this being psi, and you see it also occurs down here, we then get sort of automatically that this top black and blue line implies this bottom black and blue line. So now what we basically want to do is something like a kind of simplified cut, okay? Because I mean, we have that this red stuff implies this top black and blue line, and this top black and blue line implies this bottom black and blue line. And we really want to get that this top black and blue line implies this bottom black and blue line. So let's do this methodically. Let me just delete those bits because they're wrong. Okay. So we have that, let's call B equals A, let's call that gamma dash. And let's call B equals A and psi with x replaced with A equals psi, or with x replaced with A. Let's call that psi dash. And I've already argued that, well, since this stuff in black and blue on the right here is always true, basically, we always have that B equals A implies, we always have that gamma dash implies psi dash. I've also said that, you know, using the replacement theorem 1 with this stuff here as psi, and again, this stuff here is psi. That's psi as it occurred in the other formula. Replacement theorem 1 basically gives us this kind of sequence is true. And now, as I've already said, this thing here we're calling psi dash now. So B equals A and psi with x replaced with A equals psi, or with x replaced with A. We're calling that psi dash. And the thing that implies, according to our replacement theorem 1, is psi with x replaced with A equals psi, or with x replaced with B. We'll call that phi dash now. So in order to apply our simplified cut rule, so I mean basically what we want to get at is we have that gamma dash implies psi dash, and psi dash implies phi dash, so we want gamma dash implies psi dash. So sorry, saying again, what we want to get at basically is we have gamma dash implies psi dash, and psi dash implies phi dash, so we want gamma dash implies phi dash. But in order to do this, we want to have that for every variable that's free in psi dash is going to be free in gamma dash or free in phi dash. That's the kind of necessary condition. Well, yeah, it's the necessary condition we need to use that simplified cut result. So we just have to ask, what are the variables then that are going to be free in this? Well, we really want to do our replacement first. So what we're basically going to have when we've done this is we're going to have psi with x replaced with A is equal to psi with x replaced with A. So what are the free variables in that? Well, x is not going to be a free variable because that got replaced with A. Every free variable of x is going to potentially be in here, but that's fine because every free variable is also in gamma dash over here on the left. And also, so any free variable of A is potentially going to be in gamma dash, so that's fine. Also, B's and A's are in here, but B's and A's are also in gamma dash, so that's fine. I think that does it, and we've also got all these variables floating around in phi dash in case we need them, like the A's and so on. So I think it is true then that every variable that's free in psi dash is going to be free in gamma dash or free in phi dash, and so we can use this simplified cut rule. And so then the way this argument boils down, what this argument boils down to, is that basically then let's just make sure we've got it all right. So basically, we end up getting that B equals A implies this That's the application of our simplified cut rule. And what is this? Well, we can sort of rewrite that, because if we get this and we replace the x's in the x's with a's in this term psi, so if we replace the x's and the b's over here, it's not going to change anything. But when we replace the x's with the a's over here, we can just rewrite this as thing with x replaced with b. And there we are, which this is our replacement theorem 2. So there we have it. That makes a lot more sense now. We've gone through the details of it. So just to quickly repeat the argument basically is, think of this as alpha. This is always true. Therefore, by this kind of reasoning, A equals B implies A equals B in alpha. So we have that A equals B implies A equals B in alpha. Okay. Now, A equals B in alpha implies this stuff at the bottom using replacement theorem 1. And then using this simplified cut rule, we essentially have that A equals B, or B equals A. We can say it either way around because it's symmetric. And you can see that just by thinking about how it can be represented in equalizer. Anyway, we then have that B equals A and this stuff. So we basically then have that B equals A implies this stuff. We work out what this is, and it's psi with x replaced with A equals psi with x replaced with B. And that makes a lot of sense, okay?